So far in this chapter, we've talked about solving linear equations, which is when you just have the variable x with no exponent other than 1. We reviewed quadratics, and then now we're going to review what they call just other types of equations. So equations of degree 3 or higher, which means x to the third, x to the fourth, and so on. We're going to look at radical equations, so equations that have the square root in them already. Solving rational equations, which we did review earlier in the chapter. That's where you have fractions. And then absolute value equations. There's your absolute value signs. And then also using models, so applications and solving real life problems. Starting with the first example from the book, and then I added a couple more here, is an example. So solve 3x to the fourth minus 48x squared. Now, a very common mistake that I see, and so I left this writing on this page, is to divide each side by x squared to get rid of it. But when you divide by a variable, you divide off solutions. You lose your solution. So here it says this loses the solution where x can be 0, and we don't want to do that. So instead of dividing, please do not divide. Instead, factor, set your equation equal to 0, and then you are guaranteed that you don't lose any of your answers. So here, let's set this equal to 0 by subtracting that 48x squared over to the other side. Set it equal to 0, and then yes, they both have an x. So instead of dividing off the x, let's factor out the x. So we can factor out x squared, and we can factor a 3 out of both of these. So 3x squared, and then we're left with x squared minus 16 equals 0. And then because we only have x squareds, we can go ahead and set both of these equal to 0. So here we would get 3x squared equals 0. And then even when we take the square root of 0, our answer is still 0. So when we do the square root of 0, we don't need the plus or minus. Just 0 there. And then if we do our x squared minus 16 equals 0, I'm going to add that 16 over. And then we can do the square root again. And then here we want to make sure we do positive or negative, and the square root of 16 we know is 4. So because we have an x to the fourth power here to begin with, we technically have 4 different answers, but one of them just appears twice because we have x squared equals 0. It's like 0 is our answer twice, and then we have positive or negative 4. Letter B, we have an x to the fourth power. We could do the fourth root, but this is an example I want to show you where you have the difference of 2 squares. And when we have the difference of 2 squares, right, any even exponent is a perfect square. And then we know 100 is a perfect square. So what we can do then is we can factor into 2 sets of parentheses, and this should look familiar as we go as something that you've done before. And we know then that to get x squared, or sorry, x to the fourth, we would have to take x squared times x squared. And then the square root of 100 is 10. And to make it negative 100, we have to do 1 positive, 1 negative. Now the reason this works is because in our original here, there's no middle term, right? We just have 2 terms. So here when we distribute and we check the inside term, we get positive 10 and negative 10, and that adds up to 0. So that's why there's no middle term. So when you do the difference of 2 squares, you can always take the square root of each one and then have 1 positive, 1 negative in your answer. But now we need to solve for x. So we're not done yet. Here we've done some factoring, but now we can go ahead and set each of these equal to 0. So subtract 10. Now in this one, we have a negative, but that's okay because we've talked about complex numbers. So when we take the square root of both sides here, we get x equals plus or minus, and then remember that negative comes out as an imaginary number, and then root 10 doesn't simplify. So there's 2 of our answers. 2 of our answers are imaginary. And then we have adding 10 over. Here we'll get real numbers and we take our square root because this time we don't have a negative. Oops, no squared there. Sorry, let me get rid of that. And there we go. So x equals plus or minus root 10 there. So I have two real solutions and I have two imaginary solutions. And letter C. Now here we have a cube. Okay. So one way to solve these is I can go ahead and subtract that 125 over. And then we can take the cubed root. And the cubed root we can use our calculator for, just like we would take the square root if it were squared. And on your calculator, there is a key. It's right above the square root key. So on your calculator, above the x squared is our regular square root, but then above that you have the caret key and then a square root with a little x in the corner. That's the one that we want to use. So we have to use our second key and then click on that arrow key. And then this symbol should pop up on your calculator. And then you just type in negative 125. And because it's the cubed root, it's okay that it's negative. Any odd roots can be negative. But when you type it on your calculator too, you need to type the 3 in front. So on your calculator, I'll just go ahead and write this out. So on your calculator, you're going to do 3, and then that little square root key, and then negative 125. And your answer should just be negative 5, because negative 5 times negative 5 times negative 5 is negative 125.